Eric is here. Yay. Maybe we can like stall for a minute while Eric sets stuff up. But yeah, it's good you're here. Hi everyone. I'm one of the TAs. My name is Vivian. I think Professor Lo can do an introduction now.
Yes, wonderful. Let me just move my microphone a little bit. Okay. Hello, everyone. Good evening. I think we're going to try to do some math now. And indeed, we have lots and lots of different people here. I see that people are wondering if I'm wearing a green shirt. Well, not quite tonight. Maybe one of these days. There's going to be exciting stuff coming up on this channel. But first of all, let me just let you know what you accidentally happened upon. You happened upon an AMC 10 live solve. And what that means is that we have some problems in front of us, and we're going to try to figure out how to solve them. At the same time, our hope is that when we go and explain these questions, then you'll be able to see how people who look at a question the first time are able to think through. A little bit about us. So I'm Po-Shen Lo. I guess you know because you're on this YouTube channel. And I do a lot of very strange things. Among one of them is trying to make math really interesting. But I found out that the best way to make math interesting is if I don't do most of the talking. So actually what we're doing is that we have this entire series now where we have incredible high school students, really incredible high school students who are both brilliant at math and also really interesting people. And so now, instead of just doing all the problems live myself, I just do a small fraction of them because what you really want to do is you want to hear from the co-hosts. Actually, let me just introduce them one at a time. We have Vivian. Vivian, do you want to say a sound so that you pop on the camera?
Hi, I'm Vivian.
Wonderful. So this is Vivian. So Vivian has a background in math competitions. Actually, she also happens to have done a lot of them before and still is doing them now. And back when she was in middle school, for example, she got to nationals on math counts. And of course, this is not a middle school thing. This is a high school thing. And we have people with significant experience. They've done much more since middle school. And the other person on this is Eric Chan. Eric, does your sound work yet? Can you pop yourself on screen?
Hello, can you hear me?
Yes, we can. Wonderful. This is Eric, and Eric is from Washington. Eric is also extremely good at mathematics, extremely good. And of course, he also happened to qualify for national math counts. Unfortunately, that was in the year 2020, but we are looking forward to the return of the proper math competition season. So now, of course, what we have here is we have people who can do math problems, and we also have math problems. So I see people appear to be trying to get poop emojis through. Please don't do that, because if you do that, we might have to actually start moderating. And in case you're curious, some people might be wondering, how is it that some people get to talk? Well, the way you get to talk, I should probably let you know, is that you don't spam poop emojis. And what you do is you send messages to chat relay. So there's actually there's a user inside this Zoom meeting. It's called Chat Relay. And if you say a particularly good thing, you might actually even get a star, Maggie. And so what we want to do is that we want to make this thing as engaging of an interaction as possible. Maggie was the first one to think of that, so Maggie got the star. But in any case, what we're doing here is that we want to have this as a conversation. So you're not just watching a bunch of people solve problems. Please feel free to throw your ideas out too. And if you're watching this from YouTube, there's actually a website that you can use to go and participate in all of this. It is live.poshenlo.com/show. I hope we put it in our YouTube description. If we didn't, I'll put it there in a moment. But in any case, if you go there, you can also play in all of this conversation. With that, that's how the system works. Let's do some math. Okay, to do that, I need to change my screen. So here we go. What's up for today? All right. In order to do math, you need to have the appropriate weapon. Let's go. The sum of two natural numbers is 17,402. One of the two numbers is divisible by 10. Ooh, it ends in a 0. If the units digit of that number is erased, the other number is obtained. What is the difference of the two numbers? Oh, okay. So that means that I have a number which is like 10x and the other number which is just x. And somehow they add up to this big number. All right, everyone, let's see if we can divide numbers by 11. So I'm going to say that after you erase, that's supposed to circle this erased part. Let's call that number x after it's erased. So I think I have 10x, which is before erasing, plus the normal x after erasing is 17,402. So I guess I need to divide this by 11. So that means that x is equal to, how good are we at dividing this by 11? Well, 11 times 1 is 11. That leaves a 6, 64. So 11 times 5 is 55. 64 minus 55, is that 9? 9, 90? So then 8. 8 gives me 88. Oh, good. And then that leaves 22, 1582. So that's x. But they didn't ask me for x. They asked me for the difference between the two. The difference between the two is 9x, because that's 10x minus an x. So which of these answers looks like 9x? Here's a test-taking tip. Don't actually multiply. Go and see. If I do 9 times something ending in 2, what digit should that end in? Please type into the chat. It should end in 9 times 2. It ends in a 8. Thanks, everyone. Oh my gosh. Is there only one choice with the 8? Bam. I hope that's the answer. Is that okay?
Nice. I agree.
Yay! In that case, let's go on to the next person. We usually go alphabetical by first name. Eric, are you in a good condition to go next?
Oh, I think you're muted.
I have 2 mics and I forgot to unmute one of them. Okay, I am now ready now to do some math with you guys. But yeah, let's jump in with number 4 from AMC 10B. So at a math contest, 57 students are wearing blue shirts and another 75 students are wearing yellow shirts. The 132 students total are assigned into 66 pairs. In exactly 23 of these pairs, both students are wearing blue shirts, and how many pairs are both the students wearing yellow shirts? Okay, so there's a lot of numbers in this problem, and I usually like to organize this. Is this number theory? I don't think this would count as number theory for this question.
I think the last one kind of was.
Maybe it was referring to the last one. Yeah, probably. Okay, so I have my 57 blue students and 75 yellow students. And okay, let's do this. I'm gonna get rid of this problem for now so I have more space. I'm going to have, how many was the pairs? So it was 23 pairs, was it? Yeah, 23 pairs wearing blue shirts. So 23 pairs of both blue shirts. So how many people wearing blue shirts is that? Well, that's 46, 46 people wearing blue shirts that happen to be paired up with each other. So 46 people, blue shirts, paired up with each other. But there were 57 students wearing blue shirts total. So we could say that, well, make a nice little table here. So I have blue shirt people and I have yellow shirt people, and then I have paired with the same color and people who paired with a different color. So P. So P. Say P. Okay, we're just gonna ignore that. P same pair and P different pair. Yeah. Okay. So we have this table here. I have my 46 people who are same pair in blue, and since there are 57 total people who have blue shirts, I have 11 blue people who are paired with the yellow person. But since there's 11 blue shirted people, there has to be 11 yellow shirted people, because each blue person is paired to a yellow person if they're paired differently. So I have 11 yellow here, and I have 75 yellow students total, 75. And then that means that I have, if I subtract that, 64 students from yellow. And so we go back to the original problem. They're asking how many pairs are both students wearing yellow shirts. The answer is 32 pairs. 64 students divided by 2, that's 32 pairs. And as many people have already said in the chat, B is the correct answer. Yeah.
Yeah. Wait, never mind. You can go on.
Oh no, you could say you could.
Oh, okay, yeah. So this is a great explanation. Yeah. You basically just kind of work through it, find the number of blue-yellow pairs, and then find the number of yellow-yellow pairs. Okay, going on to the next question, unless people have other things to say. Let's see. We have number 6. Okay. Ooh, this one looks long. Okay, so we have 2 people hiking from a trailhead towards a fire tower. Someone is walking slower, and okay, so Jean is walking slower. Chantal starts walking at 4 miles per hour. Halfway to the tower, Chantal has to slow down to 2 miles per hour. Okay, and then she reaches the tower, immediately turns around, and descends the steep part at 3 miles per hour. Oh, okay, so I see. So we have two different people, and they're both kind of like going on this course. So, okay, let's see. Okay, so I'm going to draw a diagram because this is a bit hard to visualize. So first we have like a kind of flat part, and then we have like an uphill, which causes Chantal to have to go at 2 miles per hour, and then we have a downhill that is like 3 miles per hour. Oh wait, no, never mind. It's like you go up and then you come right back down. Okay, I see. So let's see. Okay, so I'm just going to like throw some numbers on this. So wait, you're hiking from a trailhead towards a fire tower. Okay, so first it's like 4 miles per hour. So like this section is all 4 miles per hour. And then this section here, going up, it's 2 miles per hour. And 3 miles per hour down. Okay. So, oh, wait, okay, I see. Interesting. Okay, so seems like they met over here. So one person went up, went straight and then up and then halfway down, and the other person just went straight and then up, I think. So I think like the second person went like this. Wait, hold up. Well, am I like missing something about this problem? Let's see. So reaches a tower, immediately turns around and descends at 3 miles per hour. They meet at the halfway point. Oh, wait, okay. Do we know like any distances? So first they're walking at 4 miles per hour. Oh, wait, okay, it says halfway. Okay, that makes it a lot more easy. So the 4 miles per hour part and the 2 miles per hour part, they were like the same distance. So it's really like, we can picture it as like a straight line, but then like halfway through it gets steep. Oh, okay, I see. So, okay, now we can like use some numbers to make our lives easier. So let's just say like each of these halves was 1 mile. So like this part was 1 mile and this part was also 1 mile, okay? So let's see how long it would take for Chantal to go all the way from here to the halfway point, all the way down and then halfway back, like half at the halfway point. So like that. So how long would this take? Well, the flat part, that would be 4 miles per hour and it's 1 mile. So that would be 15 minutes for a flat part. And then the uphill part, that would be 2 miles per hour and it's 1 mile. So that would be 30 minutes. And then the downhill part would be 3 miles per hour and 1 mile. So that's 20 minutes. Down. So in total, this would take 15 plus 30 plus 20 equals 65 minutes. And it says that after 65 minutes, so Chantal is like at the halfway point over here, and then Jean only went like this tiny little distance here. So in 65 minutes, Jean only went 1 mile, while Chantal, oh wait, hold on. Wait, yeah. Okay, so yeah, so in 65 minutes, Jean only went 1 mile. So 65 minutes for 1 mile. So I guess we want miles per hour. So 65 minutes is 13/12 hour for 1 mile. So I guess the answer would be C, 13/12, I think, because it's miles per hour. Wait, oh no, wait, hold on, never mind. So we want like miles per hour, right? So 13/2 hour for 1 mile. If we multiply this by 12 over 13, we get 1 hour for 12 over 13 miles. So I think it should be 12 over 13, I think. Hopefully this is right. Yeah, I don't know. Word
It's right to me.
problems? Is this correct? Okay, here it is. Yeah, these word
Yay!
problems sometimes like mess with you, but we finally got it, so yay.
Yay! Cool. I think I'll continue from here. Just to answer some questions about the chat, what's going on is that, unfortunately, if people are wondering how come sometimes you're saying things and they're not appearing in the chat, it's because if you say things that are maybe not so productive, then they get moderated out and you also lose reputation points. I should probably explain that. And when you lose reputation points, after you lose 3 reputation points, you actually get auto-muted. So the best recommendation is just don't make really crazy comments. On the other hand, you can see we're pretty lax in the sense that when people are excited or they say other stuff, it can go through. So this is not supposed to feel like some kind of a very dead classroom. This is supposed to feel like something where you can get excited. And occasionally, if you see something that the moderators are excited about, you might also get a star. You never know. It also depends on the moderators being available. And indeed, Maggie, you've just asked a question. The answer to your question is yes, and I'm the only one who can see it. Well, we can see it. Yes, if you get a star, you get +1 points. So then your things are more likely to appear on the screen. Okay, right. And now let's continue on to here. I don't believe anyone else has the ability to do screen share. It should not be on. If it is on, we would turn it off as soon as someone starts doing it. But you should be able to see us completely full screen for everyone. All right, let's continue. Oh, and by the way, if you wanted to write comments and you just joined the Zoom, what you do is you send your messages to Chat Relay. It's a Zoom user. You send it to Chat Relay, and there's a person. His name is Mr. Relay, and he happens to copy paste whatever you write into our screen. All right, let's continue. Mr. Joe places all the integers from 1 to 225 into a 15 by 15 grid. He places 1 in the middle square, 8th row and 8th column, and places other numbers 1 by 1 clockwise, as shown in part in the diagram below. What is the sum of the greatest number and the least number that appear in the second row from the top? Oh, interesting. So I'm just looking at this. The numbers are being placed clockwise. So I see how they're going. It's like 1, 2, 3, 4. Ah, it goes in a spiral. How nice. And it just asks to find the greatest and the least number that appear in the second row from the top. Oh, I was going to say, but it's almost done. I just have to write these numbers here and I'm all done. Oh, no, but it's 15 by 15. I see. So I need to be a little bit more careful. So, what if I think about it in terms of what's left over? If I'm thinking of going second row from the top, how is this going to end? So it goes, I'm just trying to see the spiral shape. What exactly happens here? So it goes 1 like this. So it's always going across on the top. The top is always going across and then it goes around. Oh, interesting. Does it always end in the top right corner? I'm just curious. My undo doesn't work. Oh, right, because I have not connected something. But I'm just curious. Whenever I finish a square, yeah, see, that's finishing a square. It goes across the top row and finishes on the top. And then when I go to the next row, it goes around here and it finishes on top. I'm just trying to find some kind of a pattern. So the second from the top, by the way, this is just not a fully drawn 15 by 15 grid. But what I'm seeing here is that when I'm going to do the 15 by 15 grid, let's see if I can get some space. Well, that's not really the space I wanted. But if I think of the grid, when I'm doing the entire thing, hopefully this is okay. So I'm going to imagine the whole grid. And here's the whole grid. And what's going to happen is that as I fill out the whole grid, the very last part that I fill out is going to look like this. It's going to go all the way across to here. In fact, 225 goes in the rightmost, the top rightmost thing. That is a 225, I think. And then the way you get there is by continuing to go around like this. Okay. Because I'm trying to backtrace to go and see, I see what's going on. So then the second row from the top, I'm going backwards, it looks like this. Okay, so if I see this, then you see, I don't want to make a tedious thing. I'm just trying to say the second row from the top, I already know about it. The second row from the top is going to be this blue thing. And we're supposed to get the sum of the greatest and the least. So if I look at that, I'm going to say the greatest is the last one that appears. That's the greatest. The greatest is there. So let's go and select it. The greatest is there. Oh, and that's interesting. The least is going to be the one that's right next to it because they're all increasing in order. So the least is here. So I need to add together whatever the two numbers are that go right there. All right, now let's hope that we don't make a mistake. So if 225 is that one, and if I go back, there's 15 numbers all in the top row. So this particular one will be 225 minus, is it minus 15, or do I need to be careful of plus minus 1? Well, let's think. Uh-oh, 1 second, please. I see that somebody has just adjusted the screen share piece. I'm just going to take that off. Sorry, hang on a second.
No, while he's doing that, let's how you guys doing today? Technical difficulties, huh? Not all these things go smoothly. Doing pretty good.
I guess people were experimenting with the Zoom permissions and seeing how far they could go without getting caught. I see. Some of you are pretty adventurous.
Hello. Yes, but we're back. No. I mean, the basic thing is, yes, I understand that sometimes people are curious how far you can go with the Zoom permissions, but we will always be able to get our way through this somehow. But let's continue. Make sure I read the question right, because I see some people commenting about something here. Some of the greatest number and least number in the second row from the top. So I think it's okay so far. So just to double check, it's like this is 225. So if I want to know what goes here, is it 225 minus 15? Or do I need to add 1, subtract 1? This is always how I need to be careful. My understanding is I think it's just straight 225 minus 15 with no correction. And why I say that is because like that very first one is 225 minus 0. Then the next one is 225 minus 1, and then 225 minus 2. I got to do it all the way across, and there's 15 in the top row. The last one is 225 minus 14. So that's 225 minus 15. That one is 210. But now that's not enough, because I need to know which one is next to it. And to know which one's next to it, I guess I need to subtract off all the other stuff that's here. So to go from 210, well, how many more steps do I have to take? I'm always afraid of being off by 1. Oh my gosh, the answers are all off by 1. So now I have to be actually careful. All right, so if I have this thing, how many do I need to step over? Oh, I know how I'm going to do it. I'm going to just count the number of, I'm going to count the number of boxes which are not counting the 210, but all the way around here, here, and also counting this one. Okay, and then that's going to be 210 minus something. So how many are there? Let's just count. So I will have 14 up and down here. No, I won't, because it's 15 by 15. If it's 15 by 15, I should have 13 up and down here, not counting up to there. Then if it's 15 by 15, I'm going to say there's another 14 which go up to here, go all the way across. And then there's another 13 which go up and down, again, not counting the ends. Okay. And then how many are across? Another 13 are here. Again, up to this point and up to this point. All right. So that's the total number of things I need to subtract out. Yeah, so let's go and add them all up. I have 13, 13, 13, and 14. 13 times 4, I actually know, is 52. And this is one more than that, so that's 53 of them. So that means that the very last square right here, which I'm writing in a box, that very last square is equal to 210 minus 53, because I have a 14 there. And finally, I need to get the answer. The answer is the original 210 plus this 210 minus the 53. So I think the answer to the question is 210 plus 210 minus 53. That ends in a 7. Is this okay? You can see how I'm trying to save time. I'm just like, let's see, it should end in a 7. This is not what you should actually do on the contest. You should actually be careful. So in the contest, you should say, well, that's 420 minus 53. And so 42 minus 5, that would be what? 37. So it's 367. Oh yeah, it matches. All right. Is this true?
I agree. And some people in chat agree too.
Yay! It worked. Okay. By the way, I see some people said that maybe they were a little bit confused. So the important thing was just to be careful to note which squares we are interested in, the biggest one and the smallest one, and then to be very careful about counting. How many steps do you take? Actually, I don't know. Maybe my co-hosts have a better way to explain.
No, I basically just did the same thing.
I think I would have spent just as much time. Not because, I think just out of the fear that, you get off by 1, which has happened to me too many times.
Oh yeah,
before.
that's so scary.
Yeah. Cool. Then I guess, Eric, you're next.
All right, let's see What's in store for me? Again, we have not seen these problems. Well, we have when we solved them, but it's been a year now. I think someone asked them, why did we do the 2021 fall questions? We did in a previous live stream. I'm pretty sure I remember doing that. But yeah. Cool. So let's go to question 9. What is the least possible value of x minus x? Let's try that again. Xy minus 1 squared plus x plus y squared. And I know some people want to keep the problem up, so I'm just gonna do a little bit of magic where I zoom this out as far as I can reasonably can. Okay, guys, is that okay, guys? Okay. I don't know why I'm asking. I don't really care. So least possible value. Currently in its current state, it's pretty hard to work with. So the natural thing to do would be to just expand this expression. Look at this. I'm just going to expand the squares. So if I have xy minus 1 squared, hopefully you guys know these squaring formula. So I have x squared y squared minus 2xy. Let's get the drawing up. Thank you. Plus 1. And then I'm going to add another I'm going to move this over to the side a bit. And then go plus 1 plus x squared plus 2xy plus y squared. Pretty basic stuff. I just expanded my two parentheses here. And get this all on screen. Thank you. Okay. Now I can notice a couple of things, right? Negative 2xy and positive 2xy, they cancel. So I could just get rid of them. And this expression looks awfully convenient. I can factorize this. I can rewrite this as x squared plus 1 times y squared plus 1, which is appears to be what chat is saying. Yes, chat is agreeing. So want the least possible value of this for real numbers x and y? Well, right now x and y, they're currently independent. I'm going to hide chat so you guys can see it down here. Like, whatever value of x I have in this term will not affect what comes in this term. So I can minimize this term and minimize this term, and I'm guaranteed to get the minimum value. So how do I minimize one of these terms? I just have to set x equals 0, y equals 0. That means my answer is 1, which is answer choice D. I saw a couple of people in chat talking about partial derivatives. That's not something they're going to ask you for in AMC 10. If you find yourself doing that, they can take a... Is it possible? Should be.
I don't know, probably.
Probably.
But I think this solution is a bit more natural.
Yeah, like the thing with minimum maximum with partial derivatives is a lot more complicated than single derivatives for people who know partial derivatives and yet are still here.
Yeah.
Yeah. Both x, no, because it's okay. Both x and y can be -1, not quite, because I have x squared plus 1 and y squared plus 1. And since they're square numbers and we have real numbers x and y, that means squares are always non-negative. So the minimum value of x squared I could take is 0. If I put in -1, then -1 squared becomes 1. This becomes 2. I just wanted to clear that up because someone asked about it.
Yep.
Yeah, call it the trivial inequality, basically.
Yeah. Okay, anyway, I guess moving on to the next problem. So we have problem 13. Okay. So another number 3 problem. You know what? We have not had a single geometry problem yet. This is kind of disappointing.
Good.
Okay, anyway, n is a positive integer and d is a digit such that 3 2d in base n equals 263. Okay, so we have this 3-digit number 3 2d in base n equals 263 in base 10. So then using like bases, we get that 3n squared plus 2n plus d equals 263. Just basically converting everything into base 10. Okay, and then we also have 324 in base n equals 11d1 in base 6. Okay, so we have 324 n equals 11d1 6, which means 3n squared plus 2n plus 4 equals, well, that would be 1000 in base 6, which is 216, plus 100 in base 6, which is 36, plus 6d plus 1. Okay, so I guess like simplifying this a bit, we get 3n squared plus 2n equals, because I'm just going to try to combine all the numbers and put them on one side. So we have all these numbers, we would get fish back to white, 6d plus, trying to do some arithmetic, 216 plus 36 is 252, plus 1 is 253, minus 4 is 249. So I think we now have two equations. 3n squared plus 2n equals 6d plus 249, unless I did arithmetic wrong. And then we also have 3n squared plus 2n plus d equals 263. So, okay, now let's just do a bit of subtraction. So actually, you know what? I'm going to write this in a slightly better way. So let's put the d on the same side as the 263. So 3n squared plus 2n minus equals, wait, hold on. What was it? Oh yeah, okay. So it should be 3n squared plus 2n equals, back to wait, negative d plus 263. Okay, now we can do some magic subtraction. So taking these two equations, let's subtract one from the other, and then we'll get, well, actually, no, we don't even have to do subtraction. It's just the transitive property, since these two right-hand sides both equal 3n squared plus 2n. So we basically just get negative d plus 263 equals 6d plus 249, which means 263 minus 249, which is 14, equals 7d. So d equals 2. Yay, magic, we just got a variable. Okay, now all we have to do is plug it back in. So let's make some more space. Let's just remember that d equals 2, okay? So d equals 2. And then plugging it back in, let's just use like the first one. So we have 3d squared, wait, no, 3n squared plus 2n plus d equals 263. So 3n squared plus 2n equals 261. And okay, so I guess we'll have to do some either guess and check or factorization. Which do you guys prefer? Well, I'm just going to do guess and check because I know n is a whole number. So let's see. What could n be that is close to 261 over 3? That is close to the square root of that. Well, 261 over 3 is like approximately 80. So maybe let's try n equals 7. So n equals 7, 3n squared plus 2n. Wait, actually, hold up. I think I know that n cannot be 7 because this actually must be divisible by n. Wait, yeah, I'm kind of dumb. Okay, so 3n squared plus 2n actually factorizes to n times 3n plus 2 equals 261. Okay, that's a little better. And then actually, now we can just like factorize 261 or something. So over here, 261 equals 9 times, well, I know it's a multiple of 9 because 2 plus 6 plus 1 is 9. So it's 9 times 2, 9, I think. Oh, okay, so n is 9 then. Because if n is 9, then we have 9 times 29 equals 261. Yay. So therefore, n equals 9. And we finally have our two values. 2 plus 9 is 11. So it looks like it's 11. Yay.
Yay!
Hopefully this is correct. Yay, okay.
Yay! That one worked. Okay, Eric, did you have anything you wanted to add? I don't have anything to add on that.
Oh no, not really. I think that was a pretty good solution for that. Yeah.
Okay, then let's keep going. Oh no, what's this? I just taught about polynomials today in class at Carnegie Mellon. So now I guess it comes to me, I have to do polynomials. All the roots of the polynomial z to the power 6 minus 10z to the 5th plus az to the 4th plus bz cubed plus cz squared plus dz plus 16 are positive integers, possibly repeated. What is the value of b? Okay. Oh, that's interesting. If they're all positive integers, first of all, the product of the roots, does anyone know which number is the product of all the roots? Like when you actually write down a factorized form of the polynomial, it's something like this: z minus the first root, z minus the second root, all the way to z minus the sixth root, because there are 6 of them. That's right. So the product of them is going to be, actually it's going to be plus 16. And the reason it's plus 16 is because when you multiply 6 negative signs together, you'll get a positive sign. I always have to be careful at the very, very end. It's like, is it plus or is it minus? And I go and count. Oh, yes, there's 6 negative signs. Those all cancel to be a plus sign. Yes, and the guy with pie t-shirt says it's use vietas. I saw you were the guy at Indy with pie t-shirt. Were you the guy who was at my talk in Indianapolis wearing the pie t-shirt? I'm wondering why you said Indy. Anyway, continuing on to this thing. So now we know the product is 16. And I'm just thinking, how do you get integers multiplied together to make a 16? Oh, interesting. But I also need to use this 10. Okay, so the 10 vieta, yeah, let's use vietas, because when you have this expanded in this way, then if I want to know anything about what makes the 10, well, think about how you get the 10 times z to the power 5. Ah, a guy with pie t-shirt was from Indianapolis at my talk. But anyway, if I want to use the 10 is telling me that how do I get the z to the power 5? I have to pick 5 of the z's, and then I take one of the other things, and the other things are all negative of a root. So in fact, the sum of the roots, if I think about how I got that minus 10, the minus 10 is actually minus the sum of the roots. So the sum of the roots is equal to 10. And the product of the roots is equal to 16. So I guess my question then becomes, how do I get positive integers for which they are repeated, okay? Or they have to be repeated. They multiply to 16 and they add to 10. Can I get 6 numbers? There's 6 of them. Maybe you can think of them and type them into the chat. What could the 6 numbers be which multiply to 16 and add up to 10? Well, if I use like 4, if I use 4 times 4, well, then the rest are all going to be 1s. That's too big. So it can't be 4, 4, 1, 1, 1, 1. That adds up to too much. What if instead I did like 4, 2, 2? Oh, interesting. That doesn't help. Because, well, maybe it does. 4, 2, 2, 1, 1, 1. That's 6 of them. Oh, that adds up to an odd number. But now I see. Maybe I should just do 4 2s. So are those 6 numbers which happen to add up to 10 and multiply to 16? They are. So that must be it. So these are the 6 numbers. So now I need to go and figure out, how do I get the value of b? Well, how you get b is that you need to pick 3 of the z's and 3 of the other things. They all have negative numbers. So that doesn't help me because they're all going to be negatives. Because if I think about what happens when I'm picking all the different ways of taking 3 numbers from this list, multiplying them together and adding them up, I also have to stick a minus sign in front. The reason I have to stick a minus sign in front is because it's going to be minus R1, minus R2, minus R3, and so on. So the important thing to think about is when you're expanding this, how you get the b coefficient is that for every way of picking 3 of the roots and multiplying them together, that's going to contribute with a minus sign. So the important thing is that b is going to be equal to the sum of all ways, just a second, so sum of all ways to pick 3 of 1, 1, 2, 2, 2, 2, multiply them, multiplied. Okay, and I have to think of these as 6 distinct things, by the way. So the first one is different from the second one. Okay, so the first one is supposed to be different from the second one, and so on. Well, I sort of wish they were all 2s. If they were all 2s, that'd be easier. Let me rewrite the problem that I'm trying to do now on the next page. So I have these 6 numbers: 1, 1, 2, 2, 2, 2. Okay, and there's 6 choose 3 different things that I have to deal with, which are stuff multiplied together. So I have 6 choose 3 total ways. Oh, I see. I can break these 6 choose 3 into some different kinds. One kind is that, I can do it based on how many 1s they have. Okay, so I've got one category, which is where there are no 1s. Well, how many ways are there to pick 3 of the numbers which are not 1? That's 4 choose 3. But remember, I have to also multiply them by each other. So that's going to contribute me a total of 2 cubed. Okay, I have another category where there's 1. Now, how many ways can I pick 3 things from here where I consider these to be all the 2s are different, all the 1s are different, but I need to pick 3 of them, and I need to have exactly 1 from here. Well, there's 2 choices for which of the 1s I pick. And then over here, I have to pick 2 out of those 4 2s, so that's 4 choose 2. And when I multiply them together, I get 2 squared. Does this make sense to people? I'm saying, like, if I wanted to pick 3 of these numbers, well, then I need to have, where one of them is a 1 and 2 of them are here, multiply them together, it'll always multiply to 2 squared. Okay, let's keep going. I also have the case where there are 2 1s. And that's going to be the last case because there's only 2 1s to play with. So how many ways can I pick 3 numbers where 2 of them are 1s? Well, I'll just pick both of the 1s, not much choice there. And then out of the 4 2s, I have to pick 1 of them because I need to pick 1 thing from here and 2 things from there. Okay, and when I have 2 1s, well, then that's going to contribute me just a 2 because I'll multiply 1 times 1 times 2. That's everything. So now I need to multiply these and add them up. So let's see. 4 choose 3 is just 4 because that's 4 choose 1. 4 times 8 is 32. What's this? Well, 4 choose 2, that's 4 times 3 divided by 2. Let me just do it here so that everyone can see. 4 choose 2. That's equal to 4 times 3 divided by 2, and that's equal to 2 times 3, which is 6. Okay, so if I have 6, and then that's multiplied by a 2 and a 4, so that's 6 times 8, that's 48. Wait, I'm not happy. The numbers didn't look this big. So the 4 choose 1 times 2, that's just 8. So I'm supposed to add these 3 things up and put a minus sign. Oh, it's okay. The numbers are big. So let's add them all up. 32, 48, and 8. Let's add these 2 first. These look like, oh, no, I have a better idea. Let me add the yellow ones first. That would be fun. Adding the yellow ones just gives me 40. So that means the grand total sum is just going to be 88. And I'm supposed to stick a minus sign in front. I'm going to go with A. Are we okay?
I agree with that. Yeah, I
beat me to the
basically
problem.
just did it the same way.
So how did you do it so fast?
Way. Oh, I did it like the exact same way as you. I just kind of like did it faster because you were talking, but yeah, I did the same thing, like just with less explanation.
Okay, that sounds good. Well, in that case, that's this question. All right, it looks like a bunch of people have gotten the answer also. And you're right, a lot less people are getting started. It's because we're also the moderators. So sometimes we're busy answering, like figuring out the question. With that, I'm going to toss it back over to Eric. You're up next.
Yeah, thank you. Okay. Well, let's start. Also depends on how the moderators like. Just, it's not a big deal. And then, I mean, some things that people are doing don't deserve to be starred, in my opinion. Let's talk about math. Let f be a function defined on the set of positive rational numbers with the property that f of a times b equals f of a plus f of b for all positive rational numbers a and b. Suppose that f also has the property that f of p equals p for every prime number p for which of the following numbers x is f of x equals 0. Okay. Let's dissect this, break this down a little bit, because that is a lot of words. So again, I'm going to make this a little smaller for you guys. Essentially, I have a function f. Now, I don't know exactly what it does, but they do give me a few rules for how it works. So if my input number, is a prime number, well, that's pretty simple. It's just equal to itself. I'm going to move that over to the right a bit. F of p is equal to p. And we also know that this function is additive. I think that's what they call it, additive. Correct me if I'm wrong. But f of a times b equals f of a plus f of b. Those are my 2 conditions. So let's just play around with this function. Let's disregard the answer choices for now. If I were to try to find f of 6, what would f of 6 be, for example? What do you guys, if I were to ask you to find f of 6 using these rules, okay, so I have a couple of people saying 5, a couple of people saying 6. Interesting. So let's go back to the definitions, right? 6 is 2 times 3. So I can rewrite this as f of 2 plus f of 3. Remember, we have a plus here. So since 2 and 3 are primes, they're just equal to themselves. So it's 2 plus 3, which turns into 5. So f of 6 is equal to 5. So that's kind of how this works. Okay. What if I asked you what is f of 1/2? Actually, better question. Before we do that, what is f of 1? What is f of 1? Again, I don't care about the answer choices, right? I'm just trying to figure out what this might be. So we got some people saying 0, okay, 2, 6, interesting. So our same tactic of 6 of just plugging in doesn't really work because f of 1, well, 1 is 1 times 1, so f of 1 is equal to f of 1 plus f of 1. So I don't know what f of 1 is, but now I have an equation, so it's a little bit more work, but we can still find that f of 1 has to equal 0. So f of 1 is equal to 0. Okay. So I guess more now, what if I wanted you to find f of 1/2? How would you find f of 1/2? F of 1 is, okay, so Heng-Yu Chen says f of 1 is equal to f of 1/2 plus f of 2. This is really clever because we don't always have to like put this in the a times b position. We can always say, well, f 1/2 times 2 is equal to 1. So I can say that f of 1 over 2 is equal to negative f over 2. Because remember, we already established that f of 1 is 0. And this is very important because I could apply this to any number. I could then say that f of 1 over n is just equal to negative f of n. And that is how we're going to deal with these denominators. Again, remember, I'm not even caring about these answer choices until now because I'm just trying to figure out what this function does and what things go to which other things. So let's bring these answer choices back. And there's only one way to do this from here, and that is to guess and check. I'm going to go through each one. I'm going to make this a little bit bigger for you guys. Okay. Let's go. Option choice A, we have 17 over 32. So I have f of 17 over 32. I'm going to employ the multiplication rule they gave us. So f of 17 plus f of 1 over 32. By the reciprocal rule we just figured out, we know that f of 1 over 32 is just the negative of f of 32. So I can rewrite this as f of 17 minus f of 32. 32, meanwhile, is 2 times 2 times 2 times 2 times 2. So it's f of 2 plus f of 2 plus f of 2 plus f of 2 plus f of 2. And then 17 is the prime number, so that's just 17. Well, it's 5 f of 2, so that's minus 10. So that is equal to 7. Oh no, that's not good. That is positive, and we don't want that. So A is not the right answer. How are the fractions prime? I'm just saying that numerator 17 is prime. So yeah, doesn't p have to, yeah, p has to be prime for f of p to equal, well, for the reciprocal rule, it doesn't have to be for like f of 1 over n equals negative f of n. This applies no matter whether n is prime or not, because I could always just write f of n plus f of 1 over n plus f of n equals f of 1. This doesn't depend on if n is prime. This applies to all numbers, basically. How do I verify that this is a unique function? You don't need to. Also, there's like, first of all, if in the competition setting, you don't really need to because you assume that's going to be taken care of. And second of all, there's like a set of conditions. It's really complicated to explain how this works. So just take it for granted. This is because MAA is writes the problems with a group of very talented mathematicians, and the problems are good quality, despite what a lot of salty test takers like to think, including me sometimes. Anyway, option choice B. We're just gonna do the same thing. So f of 11 over 16, f of 11 minus f of 16, which is 11 minus 8, positive. So we're gonna scrap that. Going through these pretty fast now. F 7 over 9. That's equal to f of 7 minus f over 9, which means I'm going to have 7 minus 6, which is 1. That still doesn't work. What about f of 7 over 6? Well, that's f of 7 minus f of 6, which gets me 7 minus 5, which is 2. That still doesn't work. And our last option, we know at this point is going to be the right one, but just to be super duper sure. F of 25 minus F of 11. Well, F25 is 5 times 5. F of 5 plus F of 5, that's 10. Minus 11, that's -1, which is negative. E is our final answer. I think someone asked, why is F of 1 0? If we go back to the beginning when we were messing around this function, what we could do is we'll say F of 1. Well, 1 is 1 times 1. So F of 1 times 1 is equal to F of 1 plus F of 1. So F of 1 is equal to 2 times F of 1. There's only one solution to this equation. F of 1 is equal to 0. A couple other ways you could do it. I saw some really interesting ideas in the chat, stuff like F of 1 times 2 equals F of 1 plus F of 2. That will also work. That will also get you F of 1 equals 0. So
Nice. Yeah, I'm checking all the answer choices. Like, unfortunately, the correct one was the last choice. So, like, maybe you could have gone backwards, but yeah. Anyway, that was a good solution. Okay. Yeah, I like this problem. It was an interesting equation. Number theory functional equation. Okay, next problem. Wait, seriously? We have not had a single geometry problem. Like, this is not okay. Whoever chose these problems, like, on purpose did not put any geometry. I don't approve. Anyway, okay. So what does this problem say? So we have a finite set of positive integers. If the greatest integer is removed, then the average value is 32. Okay. And if the least integer is removed, oh, so like first we remove the greatest, then we remove the least two, and then the average of the remaining ones is 35. Okay, and then we add the greatest one back, and the average is 40. Okay, and then we have one last condition, which is the difference between the greatest and the least was 72. Okay, so we've got a ton of averages to deal with. So let's see. So like total average is, but we don't even know the total average. We just know like the average when the greatest is removed. Okay, so you know what? Let's say, so because we only really care about the greatest and least numbers, we don't really care about any of the numbers in the middle. Like there's greatest over here, and then there's least over there, and then there's just a bunch in the middle that we don't care about. So let's just say that their sum is S, and let's also add some more variables. So the greatest one will be G, and the least one will be L. And then I think it might be useful to have like a variable for the number of total numbers. Wait, actually, I realize it's confusing having two S's, so maybe this can be X instead. So X is like the sum of all the numbers in the middle. And then let's say that there are n numbers total. Okay, now let's translate all the equations into equations in terms of these variables. Okay, so we get that if the greatest integer is removed, then our sum left is L plus X, which must equal 32 times n minus 1, since n minus 1 is the number of numbers we have left. Oh, Ralph said, what if we assume there is nothing in the middle? Well, the problem with that is we don't really know that there's nothing in the middle, and it would change the problem if there was stuff in the middle. So for now, we'll just call it X. Okay, so second equation. If the least integer is also removed, then our sum left over is just X, because we no longer have G or L. And then, so X must equal, oh, this is nice. X has a quantity now, so it must be 35 times n minus 2. Okay, and then last equation, actually, no, this is not the last equation, third equation. So we have 1, we have 2, and now we have 3. So if the greatest integer is returned back, so now we only have greatest and not least. So here we have G plus X equals 40 times n minus 1. And the last equation is the one that says greatest integer is 72 greater than the least integer. So now we have G equals L plus 72. Okay, so we should be able to solve this system of equations because we have 4 variables and 4 equations. So let's just try to do this in a systematic way. So first, I think it would be a good idea to use equation 4 and like, okay, so you see how equation 3 and 4 are the only ones that have the variable G. So we can just eliminate G right here because we can substitute G for L plus 72. And then the third equation becomes L plus X plus 72 equals 40 times n minus 1. which would actually, let's just leave it like that. Okay, first of all, let's think about what we actually want to find. We want to find the average value of all the integers in this set. Interesting. Okay, so yeah, I know we love systems of equations. Okay, you know what? Because it's getting kind of crowded, I'm going to hide that for now, and we can look at the answer choices later, but let's just try to solve these equations. Okay, so let's cross out equation 3 and cross out equation 4 and only look at 1, 2, and let's call this 5. Okay, so now we just have 1, 2, and 5. Well, equation 1 and equation 5 look very similar. Yeah, Caleb is correct. You can do something with equation 1 and equation 5. So because they both have an L plus X on the left side and equation 5 just has an extra 72, we can subtract equation 1 from equation 5. So it looks like this. L plus X plus 72 equals 40 times X minus 1. This was equation 5. And then equation 1 is L plus X equals 32 times. Oh, this should be N minus 1, not X. N minus 1. And then if we subtract them, we get 72 equals 8 times n minus 1. Oh, that's so nice because we can just solve for n now. So we get 9 equals n minus 1, n equals 10. Yay, we have one variable down. Okay, ooh, it looks like equation 2 can directly give us x. So let's go for that one next. So equation 2, just circle it. We get x equals 35 times 8. Okay, so we just have x. So we have x now. And maybe I'll like do the multiplication. What is 35 times 8? Eric is saying it's 280. I think I agree with that. So x equals 280. And then we just need g and l now because the problem was asking for the average of all the numbers. So average of all the numbers, let's write it up here. That would be x plus the g plus l over n. So like this is what we want. So right now we have n, x, and we just need g and l for l next because it looks like we can use equation 1. So using equation 1, we get L plus 280 equals 32 times 9 equals 288. So wait, hold on. Does this make any sense at all? Wait, is that 288? Yeah, it is. Wait, this would mean that L is 8, which is not, oh, that makes sense because L is like the smallest one. Okay, yeah, that kind of makes sense. So therefore L equals 8. And yeah, L is 8, and then G, well, you kind of can't see it anymore, but G equals L plus 72. So yeah, this is very disorganized, but let's draw an arrow over here. So G equals 8 plus 72, which is 80. Okay, so we have all 4 of our variables in scattered places on this board. So let's just do the arithmetic. I'm going to clear a bit of room over here. But basically, ooh, it looks like people already have the answer. Good for you. So all we have to do is, okay, that's enough room. So we just have to do x plus g plus l over n. That would be 280 plus 80 plus 8. Wait, this is kind of nice. Oh, okay. And then divided by 10, which is, wait, hold up. This is not an integer. Oh, well. I think the answer choices weren't integers anyways. So this would be 368 over 10, which is 36.8. Yay. Now let's go check back with the answer choices. Okay, let's clear this. And ooh, it looks like people are saying this is correct. That's good. Okay, so I think should be this one. Yay. And that is the correct answer. Yay.
Yay! That's right. That's right. So that was the right answer. Eric, did you have anything you wanted to add? I didn't have anything I wanted to add on this.
No, not really. I just thought it was kind of funny when you got confused largest with least. It happens to be a lot as well.
Yeah.
Yeah, I know, yeah.
Well, maybe there's one thing I would say, but again, I should say I'm so out of practice on this stuff in the sense that you guys are the ones who actually actively do contests as fast as you can still. When I look at these kinds of things, sometimes my hunch is to just translate all the numbers down by a bunch. So my numbers aren't as
Yeah,
big.
that's a good idea. Yeah.
So I might like just drop the 30. I might just subtract 30 from everything at first because the numbers are smaller. You know what I mean? Like if I subtract a big number like 35, that would just be, I might make a subtraction error. But if I subtracted 30 from everything, I think I can just pretend this is a 2 and this is a 5. Is that right? And this is just 10. This one's still 72.
Yeah.
But then
Yeah.
at least you're doing, yeah, that's the only one thing I would say.
Nice. And yeah, I probably could have like done the arithmetic or algebra in an easier way, but I don't know. I was just like following my instincts. Anyway.
Yes. Okay. Yeah. And of course, what you did is just great. Actually, I see that somebody said, are there no geometry problems today? I don't know what happened. In some sense, I should say we are the ones who just solved. So somehow we got the problems from somebody. And I see Eric was like quickly flipping. Are there geometry problems? And the answer is there are. But I'll just have to say, sometimes the luck of the draw is there's no geometry. I mean, this even happens. It even happens at the International Math Olympiads sometimes.
You guys are about to get lucky. There are 3 geometry questions in a row.
Right. Yes, I see people like it. So what I'll say here is, by the way, if you like this, just keep coming. So first of all, I should say, unfortunately, we've already reached our 1 hour. And so what we're doing with this is we're just doing these live solves in this particular set of the program. I think there might be one more, I forgot, or maybe 2 more at most of this kind. Stay tuned for more interesting things that will come. But if you like the way that this was taught, actually what we are doing is, if you can see, we like to teach in a hopefully more entertaining way. We think that it's very interesting to bring people like Vivian, like Eric, who are right smack in the thick of things right now, and also pretty good at very good at explaining, and also who can make the explanations look interesting. But of course, I should emphasize, if you're trying to learn for these AMCs, it's definitely good to do old problems. But if you also want something more systematic than just doing old problems, actually, there's a bunch of classes that we also run. So I should mention this. We actually have a combinatorics class and a number theory class, which are in fact both starting very soon, actually this month, I think. And so if you're interested in doing this systematically, all of this is actually on our website. This is all on live.poshenlo.com. And then you'll get to learn from other incredible people who are just like Vivian and Eric. Now, I didn't mention geometry, but if you really, really like geometry, we actually also have a geometry class. So the way that we run all of this is that Vivian, you can make a sound just because I saw you made it.
Yeah, geometry is very good. I agree with all of you in chat standing up for it. Yeah, you should definitely take a daily challenge geometry class if you want to see more of it. Yeah, I am also a very big fan of geometry, as you can tell.
Yes, absolutely. So I just wanted to simply say that. But when Vivian was doing this, I was like, oh, you guys got to see. Because you see, we get a secret back room here that you guys don't know, and we get to make faces at each other. But in any case, I just wanted to say thank you to everyone for coming. We'll be back. Stay tuned. And if you want to join the classes, we have those starting actually very soon. Those are all on our website. With that, have a great night, everyone. See you next time. Bye-bye.
Thank you, everyone. Bye.
Bye, everyone.
Hopefully there will be more AMC 10 live solves that actually have geometry. And hopefully this year's will actually have geometry. Is there, wait, what is, someone said like, is there an AMC 12 Amy one? I don't think so, just because the intended audience for like daily challenge is like young kids, and I don't think many of you are going to take the AMC 12. So just AMC 10 for now. Maybe that will be something for later.
Also, because an Amy live solve would not be fun for everyone.
Oh my gosh, yeah. Yeah.
I mean,
yeah. You guys, yeah. It would be not very much fun for us TAs struggling on Amy problems. That would be not very fun.
And
like
we would have
to get some very smart TAs.
I mean, they still give you 3 hours. Like even those problems aren't intended to be, solved with the blink of the eye, unless you are a special people.
Yeah, like you're not supposed to be able to solve Amy problems after looking at them for like a second.
Yeah, wow. So, in case you guys don't know, the AMC 10 and AMC 12 this year It's November 10th for A and November 16th for B.
Yeah, so doomsday.
And I straight up had an existential crisis when I realized I couldn't take the AMC 10 anymore this year.
Same. Same. Yeah, being old be like.
Yeah.
Anyway. We're jealous of you guys.
You guys
Able
have
to
time.
take-
You guys have time
Yeah.
to prepare and everything. But yeah, good luck. I don't read competitions. We're still
Yeah,
doing a
good
couple more
luck.
of these. Hopefully we'll see you I'll see you in some classes. But yeah,
Yeah.
thank you.
Thanks. Why are they still talking about green shirts? This is like a 2020 thing. Like, that's a very odd joke.